Good afternoon, advanced algebra students. I hope you are doing great. We are doing our lesson on 1.5 and 1.6. The topic is linear inequalities and compound inequalities. I have put them together just because they go over a lot of the same concepts and they are both very straightforward. So even when we're not doing learning by distance learning, I always teach these two lessons together. So I'm going to read you just a couple definitions, but all you need to put on your notes is what I actually put on the board. So an inequality is basically like an equation, but instead of having an equal sign, we have a less than symbol or a greater than symbol, or maybe less than or equal to or greater than or equal to. And a solution of an inequality is the value of the variable that makes that inequality true. It will always be not just one number, but for instance, x is greater than 4. So we typically do graph the solution to an inequality. There is one big difference, in addition to the fact that we normally have a graph, between an inequality and an equality. And that is that if you ever multiply or divide by a negative number, what is it that you do? I'm curious if you guys remember from when you had this before. What do you do when you multiply or divide by a negative number? If you said switch the symbol, you are correct. So let's do an example of what I mean by that. Example 1, this is a very straightforward inequality. Negative 2x is greater than 8. We're going to solve this using opposite operations just like we would an equation. So I'm going to divide both sides by negative 2. However, when I do, the greater than symbol becomes a less than symbol. Now, the other difference, as I said, is that we typically graph. When our answer has a less than symbol or a greater than symbol, we use an open circle. And when it has a less than or equal to or greater than or equal to, we use a closed circle. So to show the answer for this problem, we would do a graph. We generally put 0 on the graph, and then the number that is part of our solution, so negative 4 in this case. Because I have a less than symbol, I'm going to use an open dot. And then because my symbol is pointing to the left and the x is also on the left, my arrow is going to go to the left. So that would be the solution of that very straightforward problem. Okay, let's go ahead and do just a couple more examples of this, and then we'll talk about compound inequalities. So for example number 2, let's do 2x plus 1 is less than or equal to 6x minus 1. So 2x plus 1 is less than or equal to 6x minus 1. If I want to get x on one side, I can subtract 2x from both sides. So I'm going to have 1 is less than or equal to 4x minus 1. Then I can add 1 to both sides. So I'll have 2 is less than or equal to 4x. And then I'm going to divide by 2 and get 1/2 is less than or equal to x. Now, it is considered completely acceptable to leave our answer this way. However, for most students, they will have an easier time processing this, understanding it, and graphing it if they put the x on the left. So instead of saying that x is less than or equal to 1/2, how would I word that if I had the x on the left? X would be what? If 1/2 is less than or equal to x, then that means that x is what? It would be greater than or equal to 1/2. I generally do put my variable on the left because I do like the fact that then when I graph, my arrow is going to point the same way as the symbol. Now in this case, because I have a greater than or equal to symbol, I'm going to use a closed dot, and then I'm going to put an arrow to the right following the example here. So that would be the answer to example number 2. Now, just like when we were working with equations, you're not always going to get a number solution, or a number will not always be part of your solution. Let's look at example 3. Example 3 is negative 3 times the quantity 2x minus 5 and parentheses is greater than negative 6 So now this is gonna review a little bit of our solving of equations. We do need to distribute here. So we're gonna have negative 6x plus 15 is greater than negative 6x plus 9. Now I want to try to get x on one side, so I add 6x to both sides. When I do, I get 15 is greater than 9. Now that doesn't look like the solution that we just got because there's no x left. What do you think that means if we did everything correctly, we didn't make any mistakes, we have a statement that is true, it is true that 15 is greater than 9, but there's no x in there. What do you think the actual solution to this problem is? If you said infinite number of solutions, you are correct. Typically in this context, we can either say infinite number of solutions or all real numbers. So if we were gonna graph that on a number line, it's kind of a silly graph, but basically it would look like this. It would be all real numbers. So it would be, just a line going in both directions. So every number, no matter what you plug into this inequality, you will get a true statement. Now, example number 4 is something else that does come up occasionally. Again, these are not typically the norms. Normally you're going to have x or y or some other variable left at the end. But if you don't, for example, let's do 4x minus 5 is less than 2 times the quantity 2x minus 3. So again, we want to distribute on the right. I'm going to bring down the 4x minus 5, and on the right, I'm going to have 4x minus 6. This time, I'm going to subtract 4x from both sides and have negative 5 is less than negative 6. Now you do want to pay careful attention to this because for some people, myself included, when I first look at this, it seems, oh yeah, that sounds right. Negative 5 is less than negative 6. But remember, when we're talking about the number line, negative 5 is actually to the right of negative 6 on the number line. So negative 5 is actually bigger than negative 6. This is not a true statement. What do you think it means if we did everything correctly so far, but we're getting something that is not a true statement? It means that there is no solution. So if you had to show a graph of the quote-unquote solution here, it would just be a number line with nothing marked on it because there is nothing that works. So that would be no solution. Okay, I am going to do, I think, one word problem with you, and then we'll do a couple compound inequalities. So for example 5, I will do the word problem. I know there was one like this on the homework. So Derek wants to order some roses online. Florist A charges $4.75 per blue rose plus a $40 delivery charge. Florist B charges $5.15 per red rose plus a $25 delivery charge. What number of roses is it less expensive to order from, Florist A or Florist B? Now, interestingly enough, the color doesn't really come into play here, so I'm not sure why that was included in the problem, but really we're talking about the number of roses. So the last sentence said, for what number of roses is it less expensive to order from Florist A or from Florist B? So let's have X be the number of roses ordered. Remember, we always want to read the last sentence of our problem to figure out what the variable is, and they're asking how many roses ordered. So we're going to make X be the number of roses. Then what we want to do is come up with an expression to figure out what the cost would be to order from Florist A. So I'm going to have Florist A on the left, and I will put Florist B on the right. For me, like I said, I do like to put in words what would be my problem. And the first question says, for what number of roses is it less expensive to order from Florist A? So I'm going to write Florist A less than Florist B. And now I need to come up with an algebra expression for how much it would cost to order from Florist A. Can you take a minute and see if you can figure out what that would be? If florist A charges $4.75 per rose plus a $40 delivery charge, how would you do an algebra expression that described the cost? Well, since X is the number of roses ordered, we would write 4.75X plus 40. Then we're going to bring down the less than symbol, and let's figure out what the cost is for florist B. Florist B charges $5.15 per rose plus a $25 delivery charge. So we're going to write 5.15X plus 25. Now we do want to solve for X here to get a range of solutions. So we're going to subtract 4.75X from the left and 4.75X from the right, and we get 40 is less than 0.4X plus 25. So I'm going to do my opposite operations and subtract 25, and I'm going to get 15 is less than 0.4X. When I divide both sides by 0.4, I get that 37.5 is less than X. Now, like I said, you can leave the solution like this. I personally find it a little confusing, so I always put the X on the left. If 37.5 is less than X, that's the same as saying X is greater than 37.5. So what does that tell me? That tells me that when I order more than 37.5 roses, it will be cheaper for me to buy from florist A. Now, you can't order a half of a rose, so what we would say is that Derek must order 38 roses or more. He must order 38 roses or more. And then if he orders less than 37 roses, florist B will be cheaper, or I should say, 37 or less. Okay. All right, so I know that was a lot to go over in a short period of time. We will have time in Zoom to answer any questions you have on this. Examples 1 through 5 were just basic examples of linear inequalities, very similar to the equations that we did in our previous lessons, except for we didn't have an equal sign. We had a less than or greater than, or less than or equal to, or greater than or equal to symbol. Now, compound inequalities have the same symbols and algebra expressions, but you have more than one thing happening. So, for example, you might have, let's do example 6, 3x minus 5 is greater than 4, and negative 2x plus 5 is less than negative 25. Notice there's an and there. A compound inequality has an and or an or. If I want to solve this inequality as it's currently written, all I do is solve them separately, but put the answer on the same number line. So for example, I would add 5 and get 3x is greater than 9, and then divide by 3 and get x is greater than 3. On the right, I can subtract 5 and get negative 2x is less than negative 30. Divide by negative 2. Now keep in mind when I do that, when I divide by a negative number, I do need to change the symbol around. So now it's going to become, let's see here, x is greater than 15. So we have x is greater than 3, and then we also have x is greater than 15. Now I put this example on here because there were a couple on the homework like it. Typically, when we do an and problem, we do have the solution be between 2 points on the graph. However, there will be occasions when we have to graph both and see where they overlap, and this is one of them. So to graph the first solution, x is greater than 3, I would use an open circle above 3. And to graph the second one, x is greater than 15, I would use an open circle above 15. Now, since this is a compound inequality, we need both of these things to be true. Our solution would be the part of the graph where x is greater than 15, where they both overlap. So this one is kind of hard. Again, we're limited on time because of doing the distance learning and trying to streamline the videos. Most problems won't be this complicated. Typically, let's do example 7. I'll show you what a more typical compound inequality with an and would look like. A more standard example might be, for example, negative 2 is less than or equal to 3t minus 8 is less than or equal to 10. Notice that there's no and here, but it's understood because we're writing everything as one inequality, one compound inequality with no and here. If the compound inequality uses an or, you will always see the word or. But with an and, you can either see the word and or notice that there's 3 parts to the inequality and they're all connected. It's equivalent to having the word and. Now, when we do our opposite operations in this case, we want to do everything that we do to the left, we must also do to the middle and right. So the opposite of subtracting 8 would be adding 8. I'm going to do that on the left, middle, and right. So I'm going to get 6 is less than or equal to 3t is less than or equal to 18. Then the opposite of multiplying by 3 is dividing by 3. So I'm going to have 2 is less than or equal to t is less than or equal to 6. This is a very standard looking compound inequality with an and, because I have both numbers that are included in my answer here with a line joining the points between them. So typically with an and, your graph will look like this. Now with an or, typically your graph points in opposite directions. So let's do one example like that and we'll be done. This was example 7. I'm going to do example 8 with you. And then as usual during the class, the Zoom session, we can talk about other examples. Let's do negative 2x plus 3 is less than 5, or negative 4x minus 7 is greater than 9. Now, just like with the and compound inequality, you want to solve everything and put it all on one graph. In this case, with an or, typically your arrows are going to point the opposite direction. So when we do our opposite operations, we're going to subtract 3 on both sides on our first inequality and get 2x is less than 2, dividing by negative 2, and again, don't forget to switch the symbol around. We're going to get x is greater than negative 1. With the second one, I want to add 7. So I have negative 4x is greater than 16. I divide by negative 4, and I get x is less than negative 4. Now this is again an or compound inequality, and typically with an or, our arrows do go in opposite directions. So I'm going to have a circle at negative 1 and one at negative 4. In this cases, they're going to be open circles. This one's going to point to the right, and this one's going to point to the left. Now, I know that was a lot to go over in a short period of time. I do really appreciate you taking all these notes, and I'm looking forward to answering any questions you might have on them tomorrow during Zoom. Again, please make sure that you're pausing the video as necessary and zooming in so that you can fully see what's happening on the board. Thanks, you guys. Talk to you soon. Bye.